Hi everyone, welcome to this next video. So in this one we're going to be looking at solving algebraic fractions. We're going to go through the basics and what we need to be looking at doing to start with, and then how we can get through to solving some of the questions that we've got below and then the one on the right hand side as well. So let's jump straight in, have a little look. So first thing, with anything to do with fractions, so if we are adding or subtracting, we must make sure that we are making the bottoms the same. So the denominator must be equal. So the denominator must be the same. Now, what I mean by that is, if you had any normal fraction, and if it was over 4 and over 3, you'd make it to 12. So in this case, if we look at this, we've got 2 as our denominator and 3 as our denominator. So this one, I'm going to multiply by 3, and then that will make 6 at the bottom. And this one, I'm going to actually multiply by 2. Now, if you're ever stuck, you can always multiply by the opposite denominator. So effectively, this one gets multiplied by this one gets multiplied by this, but it's not always the case. But if you are ever stuck, that's what you can do. So therefore, what you do is you multiply the top by that value, as well as the bottom. 3 times 2 gives me 6. And then this one on the right-hand side, I do 2 multiplied by the top, and also 2 times 3, which is 6. And that will still equal 9. Okay, from there, what we're then going to do is just tidy this up a little bit. So the top becomes 3y minus 9, so we're just expanding the bracket at the top. That's still over 6. And the red one will become 2y minus 2 all over 6 still. And again, that is still equal to 9. Now we're in a position that the denominator is the same. We can actually tidy this up a bit. So now we can actually collect our like terms. Okay, so what I mean by that is the top, we've got 3y plus 2y, so that gives me 5y. And then the bottom, we've got minus 9, and we're minusing 2, so minus 11. And it's all over 6. Remember, you do not add the denominators together, you leave them as the same. And that now equals 9. From here, what we now need to do is just go to rearranging. So I'm trying to find y, which means the 6 goes over this way, and I times by 6, because it's a divide by 6 on the left-hand side. So it becomes 5y minus 11 equals 6 times 9, which is 54. Then from there, I take the 11 over. So minus 11 there. So when I move it over there, it becomes a plus 11. So 5y is equal to 65. And then finally, to get rid of the 5, you would divide by 5, because 5 times y, the opposite of that will be divide. And therefore, y is equal to 65 divided by 5, which gives you 13. Okay, so if you are not 100% sure on just rearranging and solving, I've done a previous video on that. It could be worth watching that. But obviously, that's your basics for working with algebraic fractions. So now if we look at this next example down here, we can start to see how this becomes a little bit more complex when we have denominators that are algebraic. So what I'm going to start to do here is I'm going to multiply this one by the opposite denominator. So I'm going to multiply this by x minus 4. And then this one, I'm going to multiply by x plus 1. So in the same way as up here, I multiplied this one by the opposite denominator here. I multiplied this one by the opposite denominator here. It's a similar concept. Okay. Now what that gives me is 12 brackets x minus 4, because that's what I'm multiplying this left-hand one by, x plus 1 brackets x minus 4. So that's what the left-hand fraction is being multiplied by. And this right one's being multiplied by x plus 1. So it becomes x minus 4 brackets x plus 1. Okay? And that equals minus 4 still. And let's think about what we did in the previous example. We now need to multiply out the top. So it becomes 12x minus 48. And we can actually now expand this bottom out as well. So we can multiply this out, it becomes x squared minus 4x plus x minus 4. And the right hand one, 6x, and it's 6 times 1, which is 6. And again, this is still going to be over x squared minus 4x plus x minus 4 equals still minus 4. From here, we can now just tidy up the bottom. Because both denominators are now the same, I can write it as one fraction. What I'm going to suggest we do, though, is the pink one and the red one, we actually write and put in brackets. The reason we do that is because there's a negative involved. Minus 4 plus x gives me minus 3x, and then minus 4 equals minus 4. Now, as I said, the reason that I've put this in brackets here like this is because sometimes what you'll end up having in a question is something like 12x minus, and then there might be like a minus 6x there. Or it's more common in this part where it'd be like minus 48 minus, and this could be a minus 6. So if it was like that, you'd be doing minus 48 minus minus 6, which means you then end up adding the 6. So putting it in brackets just means you don't make any silly mistakes with that negative involved. But in this case, we don't need to worry about that. So let's just look at, we've got 12x minus 6x. So therefore, that gives me 6x. Then I've got minus 48 minus positive 6, which is the same as just doing minus 48 minus 6, which ends up giving me minus 54. All over x squared minus 3x minus 4 equals minus 4. So now what we're in a position, we're in a similar position as to what we had over here, where we've created an equation that we just now need to solve. But the only difference here is this one's going to become a quadratic. So I'm still going to take this bottom value, take it over to here, and multiply it all out. So I'm going to come up here. If I do that, the 6x minus 54 is staying where it is. The minus 4 is being multiplied by the x squared minus 3x minus 4. The reason all of that is being multiplied over this side is because it's a divide on this left-hand side. Let's expand that out. So 6x minus 54 is equal to minus 4x squared. Minus 4 times minus 3 is a positive 12x. And then minus 4 times minus 4 is a positive 16. We've now got a quadratic that we're going to look to solve. So what we're going to do is we're going to take all of this over this side. The reason I'm doing that is because I need to make it equal 0. And at the moment it's a minus 4x squared. I want the x squared value to become positive. So the 6x minus 54 hasn't moved. So I can just write 6x minus 54. Instead of being minus 4x squared, it becomes plus 4x squared. Instead of being plus 12x, it becomes minus 12x. And instead of being plus 16, it becomes minus 16. And it equals 0. Let's now tidy this up. So we've got 4x squared. Then we've got minus 12x. And that is a plus 6x. So we say minus 12 plus 6, which is minus 6x. Then we've got minus 54 minus 16. That's going to give me minus 70 equals 0. Okay, now I've got a quadratic that is set up quite nicely for me to be able to solve. To make this a little bit easier for yourself, what you can identify is that these three values all can be divisible by 2. So I can just simplify this to 2x squared minus 3x, and then this will become minus 35 equals 0. Now what we need to do is think about whether or not it factorizes. And again, this is a more complex question because of the fact that the x squared is greater than 1. So if you're not sure how to factorize and solve when x squared is greater than 1, watch a previous video I've done on factorizing and solving quadratics. But just as a quick recap, we do the a value times by the c value. So I'm doing 2 times minus 35, which is minus 70. So I need two numbers that multiply to minus 70. But also I'm looking for two numbers then that add to minus 3. So one will be positive, one will be negative. My two numbers are minus 10 and plus 7. So my shortcut for this is I put 2x in both brackets. It becomes minus 10 in one, plus 7 in the other. And this left one here will divide by 2. So it becomes x minus 5, 2x plus 7 equals 0. You then make one bracket equal 0, so I'm saying x minus 5 equals 0, or 2x plus 7 equals 0. Solve it from here. The minus 5 goes over the other side, it becomes positive 5. Or we take the the plus 7 over, so it becomes a minus 7. And then minus 7 divided by 2, which you can say either as minus 7 over 2 or minus 3.5. So these are your two solutions to that question. Okay, so there's another example up here for you to have a look at. It's a little bit harder because this bottom value here and this bottom value here, a little bit harder to make the same. One thing I would say to you, if you want to pause the video and have a go at it yourself, one thing I would say to you is if you actually factorize this to start with, it may help you. Okay, so pause the video if you want to have a go at it yourself. If not, I'll go through it and you can see what I've done. So I'm going to just leave the first one as it is for now, 2x plus 1, plus, and I'm going to factorize this bottom part out. So 4x squared minus 1, hopefully you can identify as the difference of two squares. So 2x plus 1 and 2x minus 1. If it was just x squared minus 1 on its own, it would be x plus 1, x minus 1. But because 4 is in there and 4 is a square number, all you're basically doing is then square rooting that starting point as well, which is how you end up with 2x in both as well. That then still equals 3. And now, again, if you want to now pause the video from here and work it out, now you can see that this denominator already has a 2x plus 1 in it. So I only need to now multiply this one by this part, okay? So I'm going to carry on now. So I'm going to say this this fraction multiplied by 2x minus 1. So it becomes 4 brackets 2x minus 1 over 2x plus 1 brackets 2x minus 1 plus, nothing's changing here to what I've just done. That's still going to be 2x plus 1, 2x minus 1 is equal to 3. So let's expand that top part out again. So we end up with 8x minus 4 over, we can expand the bottom out now, we know that becomes 4x squared minus 1 plus 1 over 4x squared minus 1 equals 3. Collect our like terms at the top, so that's basically the same as that point there. 8x, there's no other x's, so we know it's going to stay as 8x, minus 4 plus 1 is minus 3, all over 4x squared minus 1 equals 3. Again, remembering that you don't add the bottoms together because they're already the same. Take this over that side, it becomes 8x minus 3 is equal to 3 brackets 4x squared minus 1. So 8x minus 3 is equal to 12x squared minus 3. Okay, again, we're looking at the fact that we need to make this equal 0. So this time, we're going to take these values this way because I want to leave that x squared as a positive value. So 0 is equal to 12x squared minus 3. That becomes a minus 8x and then plus 3. Let's tidy that up. Minus 3 plus 3 is 0. So 0 is equal to 12x squared minus 8x. Okay, this could become a little bit confusing to solve, but follow your process, trust your process. Again, if I was going to factorize that, I would factorize out the fact that there is a 4 in both and also an x. So 4x would go on the outside. Then I'm going to factorize it to 3x because that gives me my 12x squared, and then minus 2. From here, you then say 4x equals 0. So that effectively is one of your brackets, or 3x minus 2 equals 0. So therefore x is equal to 0 divided by 4, which is 0. 3x is equal to 2. And then x is equal to 2/3. Okay, so 2 over 3. These are your two solutions. I appreciate the fact that that one's a little bit harder to factorize and identify that it is a quadratic, but trust your process, trust in the fact that you know you need to solve it, and where there's two x values there, you're going to need to factorize out an x at some point. Okay, so that is us solving algebraic fractions. Key things to remember: when you're adding or subtracting, you need to make the denominators the same. If it was multiplying or dividing, you would just multiply the top by the top and the bottom by the bottom. But in this case, because you are adding or subtracting, you have to make the denominators the same, and that is your starting process. And then the second thing to be aware of is If there is a subtraction involved in the question, like I said here, put them in brackets just in case there's a second subtraction point. Okay, hope you found that useful, hope it helped you, and I'll see you all in the next video.